Hello and welcome to part 3 of lesson number 3 in Unit 1, Functions, in our grade 11 University College math class. This is domain and range, the wonder that is domain and range. So we have looked at number sets already. We've talked about natural, whole, integers, and real numbers, and real number sets. We've talked about domain, which is all of the x values that are part of a relation. And we've talked about range, which is all of the y elements of a relation. So domain is horizontal, range is vertical. We used number lines as a way to sort of get into what these things mean and how to use the words to create an explanation of either domain or range in set notation. We've worked through, as I said, domain and range, and now we tackled a first example where we put both of them in there together, and we considered both domain and range by sort of imagining you've got this relation on the graph and you sort of squish it against each respective axis and then see sort of what the actionable points are and what type of number set you're dealing with so that you can make a set notation for the domain and range. We're going to look at a second example now. Now this one's a little different than we've been seeing, and now you might understand why we've been talking about different number sets other than just real numbers, because here you've got this one. So if you can imagine, again, this particular relation is just made up of these 1, 2, 3, 4 points. And they, if we were to squish them down against the line, would sit here, and here, and here, and here. So again, let's just get rid of the coloring from when they were out in space. And we have, again, we're just focusing on the number line right here. We're just looking at like what's happening on the x-axis, i.e. what is our domain. So as you can see, yes, this is real numbers in that the real number set also includes integers. However, if we can be more specific than saying real numbers, because real numbers is like the broadest umbrella you can imagine, we want to be as specific as possible. So in this case, based on the information we're given, we're dealing with the number set integers. That's more specific. So we want to be using that. And again, we've got a few points here. We've got, let's see, that's like -1, -2, 3, 4, -5, and +2. So we have just 4 values. So we're going to write this particular domain in a slightly different way. So we're going to say, same as always, the set of all x such that x is an element. Now this time, we're going to do integers, not real numbers. Again, they are real numbers, but we want to be as specific as possible when we're talking about the number set. This one is going to be integers. And that's really as specific as you need to be. If we have ones that are whole or natural numbers, you can just catch them with integers. That's specific enough, I think. But we'll make sure that we talk about that when we get there. Now let's put a set of conditions on this. Now, unlike when we're dealing with the real number set, which has this sort of continuous line, this time all we've got are these dots. And because we're dealing with dots, we're dealing with very specific x values. So we can say where x is equal to 2, -1, -2, -5. I think those are the right ones. 2, -1, -2, -5. There you go. So a little bit of a different thing. Again, I wanted to sort of highlight when we're dealing with integers, you end up with this x equals rather than x greater than or equal to stuff. We're not dealing with all the little potential pieces in between. We're literally dealing with 4 values. So we have worked through the domain. Let me tidy it up a bit. Now we're going to do that same activity, but we're using that same method. We're going to imagine that we're squishing all of the points that we see, squishing them up against the y-axis. So let's do that now. We can imagine that this one here sort of squishes down and sits here. This one squishes down, sits here. This one squishes down, sits here, and this one squishes down, sits here. So let's tidy that up, and we'll look at just the stuff again that's on just the y-axis. So what are we dealing with here? Well, again, we can see that we're dealing with dots, so we're going to be dealing with integers. And what are the values that we have? Well, we have -2, -1, 2, and 4, I think that is. 1, 2, 3, 4, yep. So those we are going to put into our range. Let's do it now. So we have the set of all y such that y is an element of integers. Looks like a 2. Let's get those a little closer. 2, where y is equal to, and again, we're doing this in a descending order here. So we're doing from largest numbers to smallest. So we'll do 4, 2, -1, -2, close the bracket. Thank you, ma'am. So there we have our range and domain. This is the first time where we've seen integers, and again, just to recap that or say it again, when we're dealing with the integer number set, we don't have to deal with greater thans or less thans. We are literally talking about x or y being equal to a number of specific right on the nose values. Okay, there you go. That's example 2. Let's jump to example 3. Example 3 is missing a line on the table. I'm going to draw that in because I feel like that's going to bother me. There we go. So we have a table of values now, and this table of value has 4 points, 4 ordered pairs. We haven't been given anything else. We don't know if this is a table of values that is from a particular equation, and as such, we're going to just have to treat it as 4 distinct points. And when we're talking about points, remember that we're talking about, again, imagine on your coordinate plane here, you'd be talking about, oh, this is not great. I have to draw that a little bit differently. So you'd be dealing with -4, -5, so that'll be like down here somewhere, -3, -8, -2, -11, etc. So we're dealing with just these dots. It's not our job to connect the dots. It's our job to report what we see, and we see 4 points only. And we don't even have to graph it out, because what I know is that when we're talking about the domain, we're talking about just the x values, just the horizontal values. So we're just talking about these guys right here. And when we're talking about the y values, again, I know that we are talking about the range, and that's these guys right here. So we are going to write these in descending order, again, from biggest to smallest. So we would say for our domain, set of all x, such that x is an element, because we're just dealing with points, of integers, where x is equal to -1, -2, -3, -4. So that's biggest to smallest. And we're going to do the same thing for range. Set of all y this time, such that y is an element, again, we're just dealing with points, so of integers, where y is equal to, I forget, -14, -11, -8, -5. So there you have it. We have, oh, apparently there's a little something over there, get out of there. Okay, so there you have it. That is domain and range from our first example, a continuous relation, and from the second and third examples, just points. So all of a sudden we're getting to see the integers number set. Okay, let's keep moving. We're going to skip over all the stuff that deals with words. So this time we're actually going to be looking at some graphs and then just trying to write out the domain and the range just in set notation. We're not going to spend any more time with the words. So let's have a look here. We have a function. We have a function. We have a relation, a graph. So let's have a look at it. Again, if you can imagine, we're going to take all of the stuff you see in this graph and we are going to squish it up against the x-axis. So you can imagine that it would start here at -2, and we squish all that stuff down, so it goes all the way over here to +2, with all these little numbers in between being included. So that's going to give us a clue as to what the number, what set of numbers we're talking about. And again, we're going from -2 to 2. So let's try writing the domain out now. So the domain in set notation will be the set of all x, such that x is an element, continuous lines here, so an element of real numbers, where, so my low point is -2, we're dealing with x's, my high point's 2. So we want all the values that are less than and equal to 2, again it's going to be touching 2, but that -2 will be less than or equal to x. And again, I know I keep saying it, this is the same way as saying x will be greater than or equal to -2. It's just written backwards so that we can include it all in one statement. So there we have our domain. Let's do something similar when we're looking at the y values. So again, we can imagine we're going to be taking all of the relation and we're going to be sort of smushing it up against the y-axis. So you can see it would start up here at 5. And as we like smush all this stuff in, you can see that it's going to fill this line all the way down, going all the way down, continuous line, all the way down here to -5. So what we have is this continuous line from -5 all the way up to +5. So let's articulate that in our range. So we would say the set of all y such that y is an element of, continuous lines mean real numbers, where, so our low value is -5, we're dealing with x's, our high value is 5, we want everything to be less than and equal to 5, and we want -5 to be less than and equal to x. So there you have it. Let's tidy that up a little bit, because again, we're just getting this idea that we're dealing with just the stuff on the x-axis or just the stuff on the y-axis if you were to mush the function against it. Okay, first off, is this a function? Or I guess lastly, is this a function? Hopefully you remember from lesson 1, this is not a function in that it would not pass the vertical line test. If I were to draw vertical lines through it, well, over here I would hit it no times, so that's okay. If I drew it right down this line, I would hit it once, that's also okay. But as soon as I draw a line through here, I'm hitting it more than once, so this means not a function. Not a function, and the reason being, it doesn't pass the vertical line test. And to say that even in even fewer words, fails the VLT. Fails that vertical line test. All right, let's do one more here before we stop this video. So here we have another relation, maybe a function, maybe not. Let's start by squishing our domain down onto the x-axis. So again, imagine I'm taking all this stuff, I'm just squishing it down, squish, squish, squish. So you'll see I have an open point here, because I have an open point up at the top. But then after that, it's going to be continuous all the way over to the far side where we have yet another open. It's not a very open looking circle. Open circle. There we go. And that's going to happen at 1, 2, 3, 4, 5, 6. So that's 6. And over here, that's -6. So we have a continuous line, we know our low point and our high point, and we've noted the open circles. So let's take a crack at this domain in set notation. So we would say the set of all x such that x is an element of continuous lines for real numbers where, so low point is -6, we're dealing with x's, high point is going to be +6, close the bracket. So we want x to be less than or equal to 6. So it's going to, just less than, not equal to, because we have the open circles. And then the same thing, -6 less than x. Doesn't actually get to -6, it gets to -5.9999999, so close, but not actually to -6. So that is how you articulate your domain. Let's tidy that up a bit, and then let's go for the range. All right, range, same idea here. We're going to squish it up against the y-axis. So squish, 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 push it in. And what you end up with here is, again, an open circle up here, and then a nice continuous line all the way down here to 0, and a solid dot. Because it includes 0, we actually get there. Let's tidy it. Whoops, that's a highlighter. Let's tidy that up a bit. So there we have our number line. It's, or I guess our range articulated as a number line on the y-axis. We have 0 here, that one's important, and it includes 0, and this one 1, 2, 3, 4, 5, and this is 6 up here, and again, doesn't include 6. Let's get our range going on. So we would say, set of all y, such that y is an element of real numbers for our continuous line where, so our low point is 0, we're dealing with y's, our high point is 6, so we want values that are less than 6, not equal to, because it doesn't include it, but 0 less than or equal to y, because down at 0, as you can see, we have our filled in dot. So there you have it, domain and range for a few more examples, working with them sort of together in the same context. We're going to do one more example and then work a couple general examples, and then we'll be done. Not only the lesson, but the unit. So we'll see you in part 4.